Hello, my name is Mateusz, and today I'm gonna present you the use case 1.1. So let's start with discussing the hardware. So here we have the two platforms, the LPC 55S69, and behind it is the Raspberry Pi 4 2GB version. Yeah, and we have two UART converters connected. One is connected to the Raspberry Pi behind the LPC platform, and the other one is connected to the LPC platform, and both are directed to the PC that's right there. Yeah, and that's basically it from the hardware. Let's now switch to the workflow. So here we have a diagram of the components that are running on the LPC platform. We can differentiate two VMs. There are two VMs running under the CROSSCON hypervisor. First is the TLS client application, and second VM is basically the PUF handler VM. And both VMs use the mechanism called shared memory to communicate with each other. Yeah, and this is the client side in our demo. I will come back to this later, but yeah, this is the client running on the LPC 55S69. Let's now check out how does it look on the Raspberry Pi. And on the Raspberry Pi, we also have the CROSSCON hypervisor running and the two VMs. The first VM is the application. This will be our TLS server. And the second VM is PKCS11TA. Yeah, and both are running under the CROSSCON hypervisor and use similar mechanism to exchange information. And this is the server side of our solution. Let's now switch to the workflow and discuss how the components are interacting with each other. So on the workflow, you can see both platforms, the RPI on the left and LPC on the right, and also the VMs that are running under the hypervisor. And let's quickly go the positive route of the workflow. So basically the demo is the TLS client that does the second factor authentication of the client, and it does that by challenging the path, the hardware path that's running on the LPC platform. So the workflow starts from the LPC platform. It initiates first factor authentication, TLS first factor authentication. It does all the dance with sign request, sign response, handshake. And since this is the mutual authentication, then the handshake works both ways. So the client has to authenticate the server and the server has to authenticate the client. But the next step is the second factor authentication, in which the server must verify the client's authenticity. So as I said earlier, it does that by verifying the path. It basically changes the path and expects some kind of response in which the server can confirm the fingerprint of the NXP platform. The fingerprint is basically some unique physical capabilities of the NXP platform. It is based on the manufacturing. Basically, during the manufacturing, each platform is somehow unique, and this is how we verify. We can ensure that we have connected with the certain client. So yeah, that's basically it from the theory. I simplified it greatly, but yeah, let's proceed with the demo. Yeah, here we have the 4 terminal windows running, and this is directly connected to the UART adapters I showcased earlier. Yeah, we will be receiving a stream from the hypervisor itself, from the one of the VMs running on the LPC platform and the server running on the RPI. So let's start with the demo. We can see that here I am able to type in on the Raspberry Pi. So let's start the server. We can see it is compiled for the demo when the client is running on the NXP platform. And I also enabled debug log so we can directly see what's happening inside. Yeah, now let's trigger the hypervisor. We have to do it by triggering GDB and jumping to some certain memory address, but we already have the scripts prepared for that. So let's trigger the hypervisor and see the output on the terminal console. Yeah, I got it working once again, and we can already see that we have the output from the hypervisor itself, and on the right there is the output from the TLS client VM. The issue was basically sometimes the NXP platform hangs and the software that's used for flashing the firmware or just running the debug hangs. So yeah, I unplugged it and plugged it back again and it works. Yes, so what's happening now is basically the client attempts to connect to the server. It takes a while since there are multiple rails, but we can already see that it succeeded. So now what's happening is the server sends the PUF challenges to the NXP platform. The TLS connection has already been made, and now we are proceeding with the challenges for the PUF. This takes a while. This is very much of early stage development, so it's really slow, and that's because there are multiple buffering layers, and yeah, that's basically it. So let it finish sending the challenges, and we'll discuss what's happening further. So yeah, the challenges were sent, and we already see that the PUF is processing the challenges and outputting the responses. It now does it the local way, but once it succeeds, it will send the responses back. And yeah, this is what's happening right now. So it's now has to send all this data back to the server so server can verify the client's authenticity. Let's wait a bit. Yeah, and we've got the debug logs enabled on both sides so we can directly see what's happening. It's easier to showcase this way. Yeah, and we can already see on the server side that the server was able to verify the client. And we basically have this like giant proof script. The original script for verifying the PUF authenticity was in Sage format, so we converted it to C. And yeah, we tested it if it works and if we can break it intentionally. And from our testing, it works. And yeah, how do we know the whole workflow succeeded? Because the client was at the end able to send the message to the server, and the server responded back with the hello. So the whole process I showcased there succeeded. We had first factor authentication via TLS, and it was mutual authentication. So server verified the client and the client verified server authenticity. And then as a part of one-way second factor authentication, the server also had to verify the client by sending PUF challenges and calculating the responses to verify if this is the right machine to authenticate. And yeah, that's basically it. Thank you for watching.